Okay, in 7.3, we are going to be looking at multiplying matrices together. So this is going to be different than what we were just doing in 7.2 when we were scaling, where we would be taking a number and multiplying it times a matrix, like, for example, 2 times A. We took matrix A, multiplied it times 2. This time, instead of multiplying a number times a matrix, we're going to be multiplying two matrices together. So in order to be able to multiply two matrices, for example, matrix A and matrix B together, the number of columns in matrix A, the number of columns in matrix A must be equal to the number of rows in matrix B. So they don't have to have the same full dimensions. They just have to have the number of columns in matrix A has to be the same as the number of rows in matrix B. So if we are looking at matrix A that has dimensions of m by n, and matrix B has dimensions of n by p, these would be able to be multiplied together because they would have kind of the same middle number, where the number of columns in matrix A, this right here, is the same as the number of rows, the n, for matrix B. So as long as kind of the second number for matrix A and the first number for matrix B match, then they will be able to multiply. Then the other numbers in these matrices will tell us the dimension of the matrix that we will get after we multiply. So this will give me a matrix that is m by p. Okay, so these numbers have to match in order to be able to multiply, and then the other numbers tell me what dimensions I will have after I multiply. So we're using these matrices for our multiplication. So we've got A, B, C, and D. Since we have to have part of their dimensions match, we should go ahead and just kind of label the dimensions. That way we can use that and reference that later. So for matrix A, I have 1 row and 1, 2, 3 columns. And so we would say that this is a 1 by 3 matrix. Matrix B has 3 rows and 1 column. And so we would say this is a 3 by 1 matrix. Matrix C has 3 rows and 2 columns. And so this would be a 3 by 2 matrix. And then finally, matrix D has 2 rows and 1, 2, 3 columns. And so this would be a 2 by 3 matrix. This is going to be helpful for determining if we are able to multiply these matrices together. So the first one we got to do is AB, and that would be matrix A times matrix B. And so we just said that matrix A has dimensions of 1 by 3, and then matrix B has dimensions of 3 by 1. Okay, we can get those from right here. Matrix A is 1 by 3, matrix B is 3 by 1. So to determine if these are able to be multiplied together, we kind of just look at the middle numbers. The columns from matrix A and the rows from matrix B are what have to match. And they do. Both of these middle numbers are a 3, which means that they can be multiplied together. So the other numbers tells me what the dimensions of my product will be. I'm going to expect to get a 1 by 1 matrix. Let me see if I can make that more clear. Looks kind of like an absolute value. This should be a 1 by 1 matrix when I'm done. So let's see how we can get this product here. When we are multiplying matrices, what we are going to be doing is multiplying the numbers in the row of the first matrix times the numbers in the column of the second matrix. So what I would do is I would start, if I was multiplying these two things together, I would start by multiplying this 2 from matrix A times the 5 from matrix B. So I take the 2 times matrix A times the 5 times matrix B. Okay, then I would do the second number. So I would do the second number in the row for matrix A, and then the second number from the column in matrix B. So then I would do plus 3 times 6. So the 3 is again for matrix A, and the 6 is the second one in matrix B. And finally, we've got one more, so I would take the 4 from matrix A and multiply it by the 7 in matrix B. And so we're kind of just going down the line for both of these matrices. So let me get rid of those circles. So we get 4 times 7. Yeah, so in a way, we're simply going down the line. We multiply the 2 by the 5, then we multiply the 3 by the 6, and then we multiply the 4 by the 7. And then the result of those all added together will give me my answer for my product. So let's see. Here we have 2 times 5, which would be 10. Then I have 3 times 6, which would be 18, so I'll put plus 18. And then finally I have 4 times 7, which would be 28, so that would give me plus 28. And then I can add these three numbers together. 10 plus 18 plus 28 gives me 56. So this is my answer here. The 1 by 1 matrix, which, we have just one row and one column, so that's a 1 by 1. 1 by 1 matrix, which is the product of A, B. So then we can go on to number 2. We have matrix A, which we just worked with. That is a 1 by 3 matrix. And matrix D is a 2 by 3 matrix. That's this one over here. Okay, so we're looking at the middle numbers to determine if we can multiply. When these are different numbers. We've got 3 and 2 as our middle numbers here, as the columns for matrix A and the rows for matrix D. So since these are different numbers, these ones cannot be multiplied. So I would say this is not possible. You cannot multiply matrix A times matrix D because those middle numbers don't match. And so we can pretty much just skip that one because we aren't able to multiply those matrices together. So then let's look at AC. We know that matrix A is a 1 by 3. And looks like matrix C is a 3 by 2. Okay, so looking at the middle numbers, they are the same. So these ones are going to be able to be multiplied, and my resulting matrix will be a 1 by 2. Now, when I multiply these together, I should expect to get a matrix that is 1 by 2. Okay, so let's see how we get that. We are going to be, again, taking the numbers in the row for matrix A. So the 2 is what I would start with for matrix A. And then I would multiply it times the first number in the first column from matrix C. So I would start by doing 2 times 5. Okay. Then I would take the next number in the row of matrix A, this 3, and multiply it times the next number in matrix C. So I'm going to take the 3 times 6. And then finally, the next number for matrix A, I multiply times the next number for matrix C. So this will be 4 times 7. Let me move this just slightly. So that will give me the first number for my matrix. Then we are going to be using the same numbers for A, but this time we are going to be using it for the second column in matrix C. So we're going to be taking the 2 times this 3 for the second column of matrix C for the next number in this matrix. So this one will be 2 times 3. And then we do the 3 from matrix A, the 4 from matrix C, the second number of the second column here. And so this would be plus 3 times 4. And then finally the last number for matrix A, and then the last number for matrix C, that would be 4 times 5. So let me get that in here. Plus 4 times 5 is how we get these numbers for this matrix. Now I know that's kind of scrunched together. I'm sorry about that, but we'll just make it work. So we've got these things to multiply and then add together, and then these things to multiply and add together to get my 2 numbers for this 1 by 2 matrix. Well, let's see how much we missed. Just reset it, so we will go back through this problem and re-explain. Just for a moment. So let's see, we started with 2 times 5, and then 3 times 6, and then 4 times 7. That's what we have here. So then for the other side, we are going to be taking the 2 times 3 here. 2 times 3. And then the 3 from A times the 4 from C. So this would be plus 3 times 4. And then finally the 4 from A times this 5 from C. So this would be plus 4 times 5. Apologize for repeating that. I have no control over when my iPad does that. So when it does that, we just got to go back and do it again. So now again, we've got our 2 groups of things that we can multiply and then add together to make this matrix. We can go down the line. 2 times 5 gives me 10. 3 times 6 gives me a plus 18. 4 times 7 would give me a plus 28. So that's the first part of what I'm multiplying together here. For the next part, 2 times 3 gives me 6. 3 times 4 would give me a plus 12. And 4 times 5 would give me a plus 20. So now I just need to add these things together to get my final product. 10 plus 18 plus 28 is 56. So these 3 add together to make 56. And then 6 plus 12 plus 20 is 38. These 3 add to make 38. And so this is my final product, which does give me a 1 by 2 matrix like we expected. 1 by 2 of 56, 38. Okay, let's go on to number 4, where we're looking at DC. And so let's see. Matrix D is a 2 by 3. Matrix C is a 3 by 2. And so we're looking at the middle numbers. They are both 3, so they are going to be able to be multiplied together. And the resulting matrix should be a 2 by 2. So when we multiply these together, we should expect to get a 2 by 2 matrix. Okay. So going through these, we will start with matrix D. That's the one we have first. And so we will start with the first number from matrix D times that first number from matrix C. And so our matrix will start with 2 times 5. Then I would need the second number from matrix D times the second number in the column from matrix C. Because again, we're multiplying the row of matrix D times the columns of matrix C. And so we kind of go down the row here, and we go down the column here. And so we would take the 3 times 6. Oops. Let me finish out the parentheses here. So plus 3 times 6. And then the next one would be the next number in that first row of matrix D times the next number in the first column of matrix C. So this would be plus 4 times 7. Okay. And that gives me the first entry for the matrix. For the next one over, we are going to be looking at the second column for matrix C. So we're still going to be using the first row of matrix D, but this time we'll be multiplying it times the second column for matrix C. So I'm going to be starting again with this 2 from matrix D and then multiplying it times the 3 from matrix C. So this will be 2 times 3 here. And then I will multiply the next number from the row times the next number from the second column here. So this will be plus 3 times 4. And finally, the last number from the first row times the last number from the second column will be plus 4 times 5. I'll try not to move too far into the space for number 5, so that way we can still do that one later. So we'll close off that matrix there. And then for the bottom part of this 2 by 2, so we've got 1, 2 things here. We should expect to get 2 more things down here to make it a 2 by 2 matrix. Now we are going to be using the second row for matrix D, and then multiplying it times the first column and then the second column for matrix C. So this time we will be starting with 1 times 5. We'll take the 1 from D times the 5 from C, then the 2 from D times the 6 from C, so plus 2 times 6, and finally the 3 from matrix D times the 7 from matrix C. So this would be plus 3 times 7. Okay. And then we will take those same numbers from D, this second row, times the second column of matrix C. So we'll be using the 1 from D times this 3 from C. 1 times 3. Then, let me get rid of these circles here. Then we will be doing the 2 from D times the 4 from C. So plus 2 times 4. And finally, oops, I forgot the circles again. Finally, we will be looking at the 3 from D times this 5 from C. So this would be plus 3 times 5. Okay. Now, I know there's a lot of things going on. One thing that I want you to notice is that these numbers are the same, kind of on top of each other. These numbers are all from matrix C, from this first column of matrix C. So we're using those numbers there. And then the same thing is true on the other side, where you have the 3 and the 3, the 4 and the 4, the 5 and the 5. Those are from this second column from matrix C. And so we use those same numbers in those places. And then the other thing is true for matrix D across. We have 2, 3, 4 here for matrix D, and then we have 2, 3, 4 here. That's the first row of matrix D. And then for the bottom row, we have 1, 2, 3 for matrix D, and 1, 2, 3 for matrix D. That is from the second row for matrix D. So that kind of organizational thinking might help you to kind of keep things in the right places. Okay, so now let's go through and do this multiplication. We've got 2 times 5 is 10, 3 times 6 is 18, 4 times 7 is 28. And then for the next one, 2 times 3 is 6, 3 times 4 would be plus 12, 4 times 5 would be plus 20. Okay, going down, 1 times 5 would be 5, 2 times 6 would be plus 12, and 3 times 7 would be plus 21. Okay, and finally, 1 times 3 is 3. Let me change the blue here. 2 times 4 is 8, and 3 times 5 is plus 15. So last thing we have to do is to add all these things together. The 10 plus 18 plus 28 would give me 56. From here, 6 plus 12 plus 20 would give me 38. 5 plus 12 plus 21 also would give me 38. And then 3 plus 8 plus 15 gives me 26. And so that is my final resulting matrix when I multiply D times C. And it is a 2 by 2 matrix, just like we expected. So we've got just 2 more here. Let's see, BA and CA looks like what we have. So BA, if we multiply B times A, looks like matrix B is a 3 by 1. Matrix A is a 1 by 3. I think I actually meant to change this to something else, to be honest. I think I meant to change this to something else. So I'm actually going to skip this one because if we did matrix B, 3 by 1, times matrix A, which is a 1 by 3, would end up resulting in a 3 by 3 matrix, which would be quite a bit. So I'm going to, it is possible to do. We can multiply it. It just would take a lot of multiplying and adding together. So I'm not going to do that. So I'm going to end this video here. There might be a part 2 to this video in just a moment.